Hi again, grade 11s. Okay, today what we're going to be looking at is how to sketch these exponential graphs. And again, our formula or our equation tells us the information that we need in order to interpret the transformations of these graphs. So we're always going to acknowledge the form that this is in. So we'll start off saying in form. And our form for an exponential function is y equals small a multiplied by capital B, small b, x takes c plus d. Okay, now we have, it's already in the correct form, y equals 10 multiplied by 5. Oh dear, can you see that we have a 2 in front of the x? Remember with our completing the square and with our transformations with quadratics, we had to get x naked. That means we also need to, for this one, for our transformations, we need to have the coefficient of x equal to 1. So that means we take the 2 out. That will stay there. And we are now left with x take a half. Okay, now we can talk about what these transformations mean. So we know that our a value is equal to 10, and that means that it is not reflected. Remember, a positive a value means it is not reflected. And it is dilated by a factor of 10. Okay. Our b value, so our small b value, because we've taken that 2 out, it's equal to 2. Again, because it's positive, it's telling us it is not reflected. And it is dilated by a factor of a half. Remember, it's by a factor of 1 over b. And that will be from the y-axis. So our dilation of a is from our x-axis. And our b is from our y-axis. Now our c value, as with any of the other functions that we've studied, our c value tells us our horizontal shift. And again, we've got an x takes c, so that means that that c is actually a half. It's a positive a half. And that indicates that we are going to shift our graph horizontally by half a unit. And that's to the right. Okay, and d equals 0. There is no vertical shift. But what is important is here is where we need to acknowledge where our horizontal asymptote is. So you need to write in our asymptote is going to be y equals 0. Remember, our d value tells us what our asymptote is. Okay, now as for any graph, we need x-intercept, y-intercept, asymptotes, and if there isn't the two intercepts, we will need another point. Remember, we need at least 2 points for these graphs. So let's start with our y-intercept. And that happens when x equals 0. So that means that we have y equals 10 times 5 to the negative 1. And that means it's equal to 10 over 5 which is a nice value of 2. So that means that my y-intercept will be happening at 0, 2. Now close your eyes and imagine the shape of this graph. We know that it is not reflected about the x-axis and it's not reflected about the y-axis. That means that there will be no x-intercepts. So we need another point. Okay. And the choice of point is completely up to you. But there are certain points that will make your life a whole lot easier. And the definition of that comes down to, when you have a look at the original equation, if you can get this bracket with your x equal to 0, you will have 5 to the power of 0 or anything to the power of 0, which will always be 1. So at that point, you will have a value equal to 1, and it makes your calculation very easy. So if I selected x equal to a half, it makes my calculation easy. Okay, so choose x equal to a half. Okay, and then let's have a look. When x equals a half, should we put a little note about that? As then b to the b x minus c will equal 1. Okay, and that just keeps things simple. So you can make yourself a little note there. You want to keep your life as easy as you possibly can. Okay, so when x equals a half, let's have a look. What will y equal to? Y equals 10 times 5 to the 0 then. So y is equal to 10. So my second point will be at a half and 10. Okay, let's think about the range of this graph. We know it is not reflected about the x-axis. We know it's not reflected about the y-axis. Remember, the range is about for what y values is this thing valid. And we know that my asymptote is at y equals 0. That means that it's going from 0 to positive infinity, but it will never, ever, ever cross 0. So therefore, we have a round bracket before 0 and a round bracket at positive infinity. You could also have said my range is all of my positive real numbers. All right, let's have a go at graphing this. And I don't know how easy it's going to be for me on the screen, but I'm going to give it a go. Okay, I don't have a ruler that's easy to see. I'm going to try using these grid lines. 2, 6, 8, 10. Okay, and that's going to be at 0. And we're interested in a half, 1. We can put a couple of things there. Okay, so our first point that we're interested in is this one over here, which is at 0, 2, and I'm marking the points. We know that our asymptote is at, that's our x-axis, so y equals 0. You're going to write it. You have to write where your asymptote is. And my other point that I'm interested in is at a half, 10. Okay, I now have 2 points. It gives me the shape of my graph, and I'm going to draw a nice smooth curve through my function and label it. 10 times. Sorry. Ten times 5 to the 2x minus 1. Okay, remember to show your asymptotes, your x-intercept, your y-intercept, and label your graph. Don't forget your y-axis there. All right, the next example will be on the next video.